Hello, students. We now proceed to the chapter 1 of our ComSci 191 class. And this chapter is derived from our textbook, Computer Security Principles and Practice, 3rd edition by Stallings and Brown. The objectives for this chapter are the following. Define computer security. Second, to be able to define confidentiality, integrity, availability. Third, to describe the challenges facing computer security. Let's start with the definition of computer security. Computer security has been a subject of study for a time already. That's why some standards organization bodies have created or have established a definition for computer security. In particular, we are interested in the definition given by the National Institute of Standards and Technology in the US from their publication Computer Security Handbook. This definition is quite straightforward, but and it also encompasses the relevant aspects about computer security. It says that computer security is the protection afforded to an automated information system in order to attain the applicable objectives of preserving the integrity, availability, and confidentiality of information system resources, which includes hardware, software, firmware, information or data, and telecommunications. Now, I've underlined the important items in this definition. The first one is protection. So the goal basically is to protect something. That's the general idea about security. You want to protect something. Now, in the case of computer security, what is it that you want to protect? And that is an information system. Now, what characteristics of information or what properties of an information system would you like to protect? So we introduce what we call objectives for the information system, like preserving the integrity, availability, and confidentiality of the resources used in the information or used by the information system. So you set an objective regarding the integrity, availability, and confidentiality of the resources for the specific information system. Now, as ComSci students, you probably know already that if you have an information system, that information system would require different resources. Let's have an example of an information system that you are all familiar with. SAIS, Student Academic Information System. If you are the UP administration, and you are deploying or providing this information system SAIS, you would like to provide protection to the resources used by SAIS. What are the resources used by SAIS? It includes hardware. SAIS, of course, is running on a server. It can be a virtual machine or a physical machine, so it requires hardware. It also requires, or it is developed using software, or it uses software. The server has a firmware, and the most important resource being stored or managed by SAIS is student information and data, and of course telecommunications. So given these resources, when you think of computer security, you need to specify some objectives regarding these resources. For example, when it comes to information and or data, you don't want the data to be accessible to the public. You only want the data to be accessible to the students, to the teachers, and to the registrar and the UP administration. So that is basically the definition of computer security provided by NIST. So later, when you are asked to define what computer security is, you think of an information system, and it has resources, and these resources must be protected by specifying applicable objectives on these resources. So, as mentioned in the definition, there are three things that are important, or somehow the objectives that must be met when it comes to protecting the resources of an information system. These three items are integrity, availability, and confidentiality. Now, the next slides we will discuss these key objectives. And in computer security, you cannot say that you know computer security if you don't know the CIA triad. These are the key objectives of security. Whenever you are asked to provide security, you think of these items: confidentiality, integrity, and availability. Now let's go over to the definition of each. The first one is confidentiality. This is divided into two. The first one is called data confidentiality. The second one is privacy. When it comes to data confidentiality, the idea is that the information should not be disclosed to unauthorized individuals. For example, in the previous information system, SAIS, we don't want the grades of the students to be accessible to other schools or other students not authorized to access these grades. So that is data confidentiality. The second one is privacy. So privacy is under confidentiality. When you say privacy, it is the individual who controls what information related to them is collected and stored by whom and to whom that information may be disclosed. Basically, what it says that if the data is about you, you should have the control about the use of this data. And this is a common scenario when you register to online services. You are asked to read the privacy policy, and you are asked to determine how or to specify or to agree on the usage of your data when you access a service. Facebook, for example. So when you use Facebook, you have some privacy settings that allows you to control, let's say, your posts, who can see your post, who can read your post, etc. A loss of confidentiality is the unauthorized disclosure of information. If you've heard of the Comi leak, this was a few years back, wherein an information system was breached and the data for some voters were made available, were downloaded and distributed via torrents. So that is a loss of confidentiality, because those voter information should not be made publicly available. The second key objective of security is integrity. And there are two types of integrity. We have data integrity and system integrity. When we say data integrity, the information and programs are changed only in a specified and authorized manner. An example of this will be your grades. Okay? As teachers, we are the ones who input your grades in the grade roster of SAIS, and the information, the grades we provide is based on our computation. When it comes to integrity, if some attacker is able to change the grade of the student, then that is a loss of integrity, because it is only the teacher who should be able to change the grade of a student. The second one is system integrity. The system performs its intended function in an unimpaired manner. When you have an information system, usually that information system is designed and implemented to perform a specific function. Now, if that function is modified in some form or another, then that is a violation of, or a loss of integrity, of system integrity. An example would be some settings, changes in the settings. Okay, so when you have an information system, you would like to preserve the integrity of the data, and you also would like to preserve the integrity of the system. Whatever the system is supposed to do, it should do it unimpaired. So that's integrity. The third one is availability, wherein the system works promptly and the service is not denied to authorized users. During registration period, SAIS should always be available for students so that they will be able to choose the subjects that they're going to enroll during the semester. Now, a loss of availability is the disruption of access to use the information system. For example, a malicious user or an attacker performed a denial of service attack to the SAIS information system. One way to perform a denial of service attack is to send large volume of invalid requests to the service. For example, you all know that the entry point for SAIS is sais.up.edu.ph. An attacker can launch a denial of service attack to this URL by sending large volumes of packets, and by doing so, legitimate users, students, will not be able to connect to SAIS because the system is processing a lot of invalid requests. So that is a loss of availability, and for some systems, for some e-commerce systems, that can result to a lot of money being lost in e-commerce systems. For example, in Lazada, if you are a fan of Lazada, and if, let's say, during a sale like 9.9 or 10.10, a lot of people will try to shop. So what will happen is, if the people will not be able to buy from Lazada during that period of time, then the revenue will be lesser. Okay, so that's availability. So at this point, I hope that you now realize that as computer science students, all right, you are developing systems, you are developing programs, but you also have currently your focus only is on implementing the functional requirements of the applications. But once that application is deployed or is running, now these things will come in. But the idea, that's why you are studying ComSci 191, is to make sure that while you are still designing and implementing the functional requirements, you can already factor this in the confidentiality, integrity, and availability while you are still designing and implementing your systems. So what I want to emphasize here is that security should not be an afterthought when developing your programs. From the moment you describe the functional requirements, you have to consider security in developing these systems, because nowadays it's very easy to perform attacks against information systems and violate this CIA triad and fail to achieve this CIA triad. Now, in addition to the standard CIA, we also, in computer security, we also consider authenticity. Authenticity would mean the property of being genuine and able to be verified and trusted. In your email, for example, before the introduction of two-factor authentication, you are only required, when you log into your email, you are only required to supply your username and your password. Now, an attacker can actually simulate that the login process by automating the supplying of username and password. And the system, if you are able to supply that, the username and the password correctly, the information system will think that you are the authentic owner of that account. But nowadays, that is no longer true, because certain attacks can be automated. That's why they introduced two-factor authentication. You no longer need to just supply the username and the password, but you need to have a second way of providing your identity, so that the system will know that indeed you are the owner of that account. So personally, I use the Google Authenticator to generate codes that I will input in addition to the username and the password. So that's authenticity. And in computer security, usually this is accomplished by cryptographic operations, which we will discuss later. Then the second one is accountability, in which the actions of an entity need to be traceable to that entity. When I log into an account, then the system should be able to tell that I indeed logged in to that account. So that is accountability, and my action, that the actions performed on that system can be traced back to me. I cannot, let's say, argue that I did not use that system during these days. The system should be able to tell that you use this system during this day and time, and this is what you did while you are logged into the system. That is accountability. That's also considered in as one of the key objectives of security. So I guess you are all now familiar with the CIA triad. Now, let's talk about the levels of impact of a security breach. A security breach is a violation or a loss of confidentiality, integrity, and availability. Any loss of those can be considered as a security breach, but not all security breaches are at the same level. We can actually provide it has actually different levels depending on the impact of the security breach. We can categorize a breach as a low level, has a low level impact if there is a limited or minor adverse effect on the operations, assets, or individuals. We will give an example later on how we evaluate the level of impact of a security breach. But somehow when you say low level impact, that means the effect is very minor, sometimes just a minor inconvenience. The second level is called is the moderate level. Now it has serious or significant adverse effects on operations, assets, or individuals. So when we talk talking about SAIS information systems, if for example a user or a student is not able to register because of a denial of service attack, then that can be somehow considered a moderate level of impact, because even though the student was not able to register during the designated date and time, he can still go through the manual process and still get registered. So that's somehow moderate. Then the last level of impact is the high level of impact. It is a severe or catastrophic adverse effect on the operations, assets, or individuals. So when assessing the level of impact of a security breach, we look at the effects on the operations, on the assets, or the individuals. So the individuals are the users or the entities or the data or the entities that contain that provide information to the information system. So that's what always you have to consider. Okay, so there is a security breach that happened. What is the effect on the operation, on the assets, or the individuals? Now, in the case of a high level impact, let's say you have an information system, hospital information system, and the integrity of the data in that hospital information system has been tampered with, then that is catastrophic, because the information might be wrong, and for example a different medicine or procedure might be administered because the data was compromised. A common example I read lately about a patient dying because of a ransomware attack in a hospital. So imagine, when you say ransomware, when you say ransomware, it's a form of malware wherein it encrypts the entire system, and you can only decrypt the system if you pay a certain sum of usually cryptocurrency to the attacker, and then they will give you the key and your system will be restored back to its normal operation. So I read somewhere that a patient died because of a ransomware attack, because the data about that patient is not accessible. So that is basically a high level of impact, a high level impact security breach, and that's dangerous. It is my observation, personal observation, that most computers in hospitals are actually not updated, and old malware can actually infect this hospital information system. In some old hospitals, I can still see Windows XP being used by some of the staff, and Windows XP is full of holes and it can easily be targeted by a ransomware attack. So we now proceed to get a better view of the relationship between the levels of impact and the key objectives. So let's start with confidentiality. So this objective, confidentiality, and we give some examples of high level impact, of high, moderate, and low levels of impact of violating this particular objective. So in terms of confidentiality, grade information, a violation of or unauthorized access to grade information is a high level impact. Because in some countries, like in the US, the access to the grade information is limited only to certain entities. So if your grades gets released publicly, then that is considered a high level impact security breach. The second one is enrollment data. So an enrollment data, if it gets leaked, is of moderate impact. And then the last, the low level impact regarding confidentiality is the student directory. So normally the student directory is public, so it doesn't really matter that much if it gets leaked. Now we move on to integrity. So a violation of integrity, as I mentioned earlier, hospital information system. If the integrity of the data and the system in the hospital information system is compromised, then that can be considered as a high level impact security breach. Now, about website forums, I'm sure some of you frequently visit these website forums, usually for hobbies or some geek culture. Okay? A violation of the integrity of those types of systems of forums doesn't really affect much the operations, assets, and individuals contained in these forums. Then the last one is an anonymous online poll, which does not really a violation of the integrity does not really affect the, or the impact is not really that big if the data in the online polls usually are not somehow treated seriously. Okay, the last one is availability. So the objective is availability. A violation of or a loss of availability in authentication services can be very high. An example of this will be the Google login. Okay? A lot of services, third-party service or other services, allows you to authenticate using your Google account. The idea there is that if you have your Google account, you can use it to log in to other services. Now imagine if the Google authentication services is down. Not only you cannot log into Google, but you cannot also log into other services that authenticates using the Google authentication service. So that's a high level of impact security breach. Now the university website, if actually nobody cares. For example, if ICS is down, ICS website is down, nobody cares. Nobody is looking at ICS website. If UPLB website is down, only a few individuals notice that UPLB website is down. So it's a moderate level of impact. And the online phone directory. So if the online phone directory is not available, it's okay. There are other ways to find the location or the phone number. So this ends the discussion on the CIA triad: confidentiality, integrity, and availability. So we now move on to the challenges of computer security. This is an interesting discussion because during the early days of computing, security is not actually considered that much. I recall when I was still using an ordinary computer running on the DOS or the disk operating system, we don't really have some protection mechanisms in place during those days in the case of MS-DOS. Perhaps because of the challenges, or the need is not yet that important, or it's not yet needed, the security aspect of computing during those days. But nowadays it's very important because we are now in a connected environment. Unlike the days I remember, the only problem that I encountered are computer viruses that spreads by inserting floppy disks from one computer to another. So, for example, I bring my diskette to a computer shop and then I go back to our school lab. Then there is already a virus on that floppy disk. Anyway, the next item on our list are the challenges of computer security. Why is computer security challenging? The first one is that the mechanisms to meet requirements regarding security are quite complex. Okay, it's very easy to say we should consider the CIA triad, but how are we going to implement them in the computer, in the system? So these mechanisms are actually challenging. For example, confidentiality. So if you want to preserve confidentiality, you need to provide some mechanisms so that only authorized individuals will have access to the data or whatever is stored in the information system. How do you do that? So the mechanisms are quite complex. The second challenge is successful attacks are designed by looking at a different perspective other than on which the security mechanism or algorithm was originally based. Okay, so a good example of this is in cryptography. Okay? In cryptography, we have different algorithms, and these algorithms somehow have different ways of doing things. However, these cryptographic algorithms depend on a random number. For example, in the generation of keys, random number. No matter how complicated your cryptographic protocols is, if your random number generator can easily be compromised or a random number can easily be predicted, then your cryptographic operations or protocols is useless, because the attacker can predict the keys, can predict the parameters of your cryptographic protocol or algorithm. So an attacker usually do not look directly at the mechanism or the algorithm. So it tries to look for other ways of bypassing the security. Sometimes we have what we call a common nowadays is called side channel attacks. So in side channel attacks, the attacker does not need to directly attack the system. It simply listens or tries to analyze some patterns in the memory access or cache access, and they are able to retrieve data stored in the memory without directly attacking the system. The third challenge is computer security mechanisms will not make sense until various aspects of the threat are considered. Okay. The idea here is that there are many things to consider when designing security or creating security mechanisms. And initially, you will always wonder, why do we need this protection? Why do we need an antivirus? Why do we need a firewall? Why do we need this perimeter intrusion detection system? Right? So it has a lot of moving parts, and we need to be able to identify to consider the entire threat landscape, to be able to say, this makes sense. We need to place an antivirus in the machine to protect us from malware or remote access toolkit, etc. So the fourth one is decisions must be made on where to place the various security mechanisms. Okay, so we've developed a security mechanism in order to avoid a particular, to prevent or to avoid to address a particular threat. Now, where do we place this mechanism? So placing them can be a matter of physical location or a logical location. For example, in UPLB, in the design of the UPLB perimeter network, there is a question of where should we place the firewall appliance. Should we place it after the border router, or should we place it before the border router? So those things need to be considered. Now, in the logical, we can think of this in networking, in protocols. In the case of TCP/IP, okay, so normally we can look at TCP/IP as 4 layers. So we have application, transport, network, okay, media access. So where should we place for example, the encryption? Should we place the encryption in the application layer? Should we place the encryption in the transport layer? Should we place the encryption in the IP layer? Or should we place the encryption at the media access layer? So you have to decide where should we place the security mechanism. Then the next challenge is security mechanisms involve more than one algorithm or protocol. So this is in relation to this challenge, to this number 2. Okay? So in a similar way, a mechanism usually is not just a single algorithm or standalone algorithm. So usually it is a combination of several components, and if a component fails, then the entire chain can actually be compromised in the security mechanism. So that is an important challenge in computer security. For example, if your security mechanism involves timing, then if the operation, if the network or a protocol, let's say, introduces or has variable delays because of different environments, then the timing parameter will be useless in your security mechanism. Okay, the next one is the designer must think of all the possibilities and the attacker needs only one attack point. This is very true. Okay? If you are thinking of implementing or preventing the attacker from attacking your system or the information system, you have to think of all the possibilities if you are the defense. But if you are the offense, you only have you only need one attack point. This is very similar to the security in your houses. Okay? If you are the owner of the house, you try to make sure that the windows are locked, the doors are locked, but the attacker can go through the ceiling, through the roof, and then enter your house through the ceiling. Only one, even though all the doors are closed, the windows are closed, but through the roof and the ceiling, the attacker can infiltrate your homes. So this is the same way these things in computer security. So popular nowadays is what you call the bug bounty program. Okay, so when you say bug bounty, when you find loopholes or vulnerabilities, you report that to the company, and the company will pay you certain certain amount of money, monetary reward, for finding and reporting that particular vulnerability. So as an attacker, you only have to find a way to break into the system. Then the next one is little or no investment in security until security failure occurs. So this is also very true, especially in some organizations wherein they think that security is not important. They will only invest in security until there is a security breach that occur. Okay, and an example of this is, for example, website defacement. Typical examples of this is website defacement. And in the Philippines, the common target of website defacements are websites owned by LGUs, and lately there have been attacks on university websites. So let's say a state university or college, or even UP, they set up a WordPress site, a Joomla site, or a Drupal site without considering the security settings when they deploy these sites. Or a student was hired by a unit to develop a website, and then that website is deployed immediately without testing. Eventually that site will be hacked or will be defaced. That is only the time that the organization will consider security, only after a failure occurs. Another challenge is that computer security requires regular monitoring. A typical example of this is, let's say a website is running, let's say the ICS website. The ICS website is running in an old version of Drupal. Okay? Now, eventually, attackers will be able to find certain vulnerabilities in Drupal that can be exploited. If the security of the ICS website is not continuously monitored in such a way that patches or updates are not applied, it is possible that the ICS website will be compromised. I recall one instance of this when a few years back, the UPLB website was defaced by Chinese attackers simply because the staff was not able to update the UPLB website to a newer version of the content management system being used. So that's a problem. Security requires regular monitoring, or in your case, in your personal computer, for example, how often do you update or how often do you apply updates to your system? So in my case, because of these things, I always update my system. During the early days, I thought that updating my system is just a waste of time, but I realized that it's very important that you always update your system to be able to patch certain vulnerabilities. The next challenge is security is still often considered after the design rather than being integrated in the process. So this is what I was saying earlier. When you take ComSci 191, after taking ComSci 191, what we want you to know is that right from the start, when you develop an information system, you should already consider security, because currently security is just okay, I've built the system, I deploy it, and then the system get hacked. That's the only time that I will consider security and improve the system. Because initially, during the implementation, the design and implementation of the functional requirements, you did not even consider security during those times. So that is a challenge. How do you make developers understand, or architects, that right from the start you already have to consider security, not after deployment? This is very important in SP students. They develop their SP, and then the SP does not even consider security in their design. Okay. And then I think this is the last. Is this the last? Yes, this is the last. Okay. The last challenge is that security is often viewed as a hindrance to efficient and user-friendly operation of information systems. Okay. Before the introduction of the two-factor authentication, it's very convenient to use just the username and the password. And then when we switch to two-factor authentication, it's very cumbersome to look at your cell phone and then get the code and then plug it in to the prompt. Right? But eventually you get used to it. So most people would just would consider security as a hindrance to the efficient and user-friendly operation of the system. And another example of this will be password choice, the choice of password. Right? It's always suggested that when you write your password or when you create your password, it should be a combination of uppercase, lowercase number, and symbols. That should be not be your birthday. But most users still use the 1234 and QWERTY as password in some of their accounts because it's very inconvenient to memorize a complicated password, and also password reuse. It's always advised that you should use a different password for each account, but still users make use of the same password for different online services that they subscribe to or they use. So the goal of ComSci 191 actually is to help you out with these challenges, to make you understand these challenges, and then somehow incorporate in your practices as computing professionals in the future these concepts so that you will not regret being hacked or your systems being compromised. So we'll stop here and then we will proceed to the next section in the next video.